Right, yeah, so good afternoon, everyone. It's 3 o'clock here in Belgium, so we can start with the webinar. First of all, I'd like to wish everyone a good morning, good afternoon, or good evening, depending on where in the world you are. It's another very global audience today, so thank you for taking the time to join our webinar with INRIX, entitled Smarter, Cleaner, Safer, the Future of Self-Service Mobility Analytics. First, I'd like to introduce you to our two speakers. First of all, we have Bart Adams on the left. Bart is the founder and CTO of XYZT.ai. He's held senior leadership positions at Luciad and Hexagon, where he was the product management director and chief innovation officer. Bart holds a PhD in computer science from the KU Leuven and a postdoc from Stanford University. On the right, we also have Holger. Holger is INRIX's Director of Sales and Business Development and has been with INRIX Europe since 2014. He is responsible for the public sector and business customers with a current focus in the area of traffic management and smart cities. Holger has over 25 years of experience in IT, telecommunications, and the location industry, and has worked in various sales and project management roles at corporations such as HERE, Navtech, CGI, Logica, and Hewlett-Packard. Holger holds a master's degree from the Technical University in Munich. So thanks for being with us today, Holger. It's much appreciated. So onto the agenda slide. Let's take a look at what Bart and Holger will be presenting to you today. First of all, we'll jump into the presentation, starting by setting the scene and introducing both companies. Bart will then show 3 use cases that showcase INRIX's trips data and how that fuels the XYZT.ai platform. For some interactivity during the presentation, we'll run 3 polls, as we'd like to know your thoughts on a few topics. Actually, there's 4 polls, I should say. We'll then wrap up with some key takeaways, and at the end, we'll have some time for questions and answers. So before we get started, a few housekeeping rules. If you do have any questions during the webinar, please ask them via the QA box or in the chat area. We'll try and answer as many of them as we can, time permitting. Depending on how many we have, if we don't get around to all of them, then we'll provide answers to your questions directly via email. The webinar is recorded and we'll share that with you as soon as possible after the webinar. So now, without further ado, I'll hand over to Bart and Holger, and I'll see you a little bit later for the first poll question. So over to you guys.
Okay, thank you, Joe. Thank you all for joining us. And special thanks also to Holger and INRIX for being a guest on our presentation today. Thank you, Holger, for being here. So let me just jump in and set the scene a bit. This is you, and even with the whole work from home COVID policies, this is still you. And this is also you, stuck in the subway, unfortunately. And I hope this wasn't you. And if this was you, I think many people were waiting for their package because of you. And yeah, this is a huge problem still in many areas, in many domains. But luckily, there's technology that is tracking you. And I'm really saying luckily, even though some people might think that that's a bad thing. But this technology that tracks our cars, that tracks you when in the subway, and that tracks the vessel and the packages, is actually driving our economy. And these technologies, they generate a lot of data sources that for many organizations, for many businesses, for many cities, are still untapped resources. And for that, these data sources are sometimes called alternative data sources. And I chose this image because I think it's a bit speaking. And if you don't start using these types of data sources, you will be left behind, and you will end up like a small forgotten ghost town in the Midwest, or a forgotten car maker or whatnot. And we will miss you, not just us, but also INRIX and the others that are making use of these data sources. So what is the objective of tracking us and tracking cars and tracking people and tracking the whole logistics chain? And one of the keywords that we like to use are smarter, cleaner, and safer. And those are also the keywords that the EU is using in their Green Deal. So the objective is to use this data for good, to make smarter cities, cleaner environments, cleaner cities, and also safer roads and safer cities for us to live in and also for our children to live in. To set the scene a bit, like how long does it take, do you think, to get new traffic cameras installed if you want to start monitoring traffic? It typically takes months, but maybe even years if you have to take the whole tendering and construction process into account. How long does it take to buy floating car data? It only takes minutes, and that's a huge difference. And there's also a saying that, like, to cover 1 mile of road with infrastructure and to maintain that infrastructure, it costs you $1 million to do so. And that's a big cost that can be avoided by looking into the alternative data sources. Now, not all is as easy as just buying this data, because if you start looking at the data, and Holger will talk about that in a minute also, the data is really big. Think about all those cars, all those movements that are being tracked, generating location records every second, every minute, at a frequency that is really, really high, and it generates just a lot of data. And this is an actual saying from one of our customers, where they said it takes on average 3 months for our data scientists to start extracting insights out of this type of movement data. And with your tool, we could do it in half an hour. And that's actually why we are in business, why we built a platform to work with this data. Sadly, this is also a true story. And this is an actual organization that we've been talking to, 65,000 employees, and they have 2 data scientists. And I think for the data scientists in the audience, this is probably very recognizable. Those data scientists, they become the bottleneck. They become over-demanded in having to solve all types of analytics questions for the different business units. So basically what happens, if you are one of those 65,000 employees in the organization, this is where you are. You're stuck in a line waiting for those data scientists to get started on your job. And that's also what we want to avoid. So how long would it take now for organizations to work with this big data? It takes months. And what we are trying to do with xyzt.ai is to make sure that you can do the same job in minutes, saving you those months of time and over demand for those data scientists. And that, Joe, brings me to our first poll question.
Certainly does. Okay, so poll question 1, what are the key bottlenecks in your organization? So the answers are, we don't have data, our tools can't handle the data, we only have a few people who can extract insights, we can't visualize and communicate the results, or none, we're already smart and fast. So let me launch that poll. Should be in front of you now, so if everyone would like to make the choices. Okay, we'll give another few seconds, last few answers coming in. Okay, there's a few still coming in, I can see. All right, let's stop it there. Okay, I'll end the poll and I will share the results. There we go. So a bit of a mix across the board.
Okay, it's a good mix between different things, and 13% is already smart and fast, so that's good. Okay, let's move on. And that's exactly why we are in business. So many people don't have data, many people don't have the tools to extract the insights and to visualize and communicate those insights. And so that's why we built xyzt.ai. XYZ comes from location and 3D coordinates to pinpoint something or someone in space. T comes from time, and AI from artificial intelligence. And we basically bring a platform to market, and I will show it in a minute, and in the use cases and demos, I will show it for a very long time. We provide a self-service analytics platform, really targeted towards you to use the platform to extract insights. We run it in the cloud, software as a service, so it means that we also take care of the infrastructure, the storage, and so on. It scales to billions of location records, and that's really necessary, and we will talk about that later with the data from INRIX. But what's really nice about the platform is that from day one, you can ingest the data and you can start extracting insights easy and effortlessly, and also communicate those insights to your stakeholders. And just to give you a little sense of what the platform is, I'll show you just a couple of minutes, and now I'll give the word to Holger from INRIX to talk a little bit about the data that we put in the platform. So for that, I'm going to open my browser and I'm going to navigate to the platform. So it's a SaaS platform. It's accessible anywhere, anytime, from any device. We also engineered it so that you can even open it on your smartphone if you want and do all the analysis on those billions of points. In the platform, you can log in with multiple users in your account, and you can work with multiple projects, multiple data sets. And what's really important to realize is that it's a bring your own data platform. So basically, you can ingest any data in the platform. And let me show you just this first project here, where Holger and his team from INRIX were so kind to provide a sample data set in the platform. And actually, if you register to our free trial, this is the data set that you will be able to play with. Now, let me show you first what you see on the screen. Basically, what you're seeing is 1 week of floating vehicle, of moving vehicle data through the city of Hamburg, which is a major city in Germany. And you see those data points visualized in many different ways. This is hundreds of millions of data points. And you see on the map, you see a heat map, basically showing where the data is. Where are those cars moving during that week of time? At the bottom of the screen, you see a timeline, and the timeline shows a histogram. It shows over time how many trips are there in the view. And that gives you an idea of how busy it is over time. And a trip is defined as basically a movement from a car or maybe a bicycle or a person from one point to another. So for example, when you go to the office, you get out of your home, you get into the car and you drive to the office and you get out of the car again. That's considered a trip. You see there's about 1 million trips in this data set that you see here on the right. And what you also see on the right, and we will see many more of those little widgets later on, you see some statistics on the properties in the data. And you see the velocity profile, you see the total distance of the trips, you see the heading. And what's really special about our platform is that our platform can handle billions of those data points and still allow you to do an interactive analysis. So for example, when I zoom in on an area, what will happen is it will fetch more detailed data. It will update all the other statistics while doing so, allowing you to get insight out of that data. As you can see, when I zoom in, at some point, you will see those individual data points. And those individual points are called waypoints in the TRIPS dataset. And those are actually locations of a car, vehicle, at a certain point in time, together with all those attributes. And later on, I will go into this data set and show you a case of an analysis that is quite common for an analyst for a city to do with this type of data. But first of all, I think I want to give the word to Holger.
Yeah, thank you. Thank you, Bart. Yeah, I just want to tell you a little bit about INRIX as such, and actually what we're doing and which role we are playing here in this entire game here. So yeah, INRIX, first of all, is a US-based company headquartered in Seattle, not far away from Microsoft campus, which is not just by accident, because INRIX is actually a spin-off back in 2005 from Microsoft. And We currently have around 400 employees. Majority of that is based in Seattle, especially when it comes to development. So the INRIX, the business where INRIX is in is actually the movement data as such. So, and the main use cases and the heritage where we are coming from in history is for automotive industry. I mean, think about the real-time traffic for navigation systems, for example. But over time, more and more, it turned out that INRIX is moving into the public sector. For example, cities, traffic agencies, all for traffic analytics purposes, including real-time traffic for traffic management centers and so on. Additionally, we are serving enterprises like real estate, insurance companies, and so on. So what INRIX basically is a data provider and finally a data aggregator. And this is really helping to support the slogan from today's webinar, smarter, cleaner, and safer, because that is actually how our data is supporting these things. Next slide, please, Bart. Yeah, and so INRIX traditionally is, as I said, a data provider, but we are stepping more and more into a role of a SaaS company, so software as a service company. And what you can see here is actually a few of our already developed software tools, which is based and using our data. So, for example, like road analytics, signal analytics, a very new service we are just launching, and of course, trip analytics. And here it comes that this is the perfect fit with XYZ-T, and as Bart already said, XYZ-T is in the SaaS business as well. So XYZ-T has the tool and we have the data, and that is actually the perfect fit here. And so you can use this tool to easily get insights for traffic patterns, spatial behavior, and whatnot. It's easy to use. It enables our customer to get deep insight without building own big data scientists and capabilities and this kind of thing. Bart has already mentioned that. So that's a perfect fit. But what is actually all about the data? Where is it coming from? And here is actually one slide which shows it all, more or less. And you simply have to read it from left to the right. So it all starts, of course, with the input data. So where is it coming from? It comes for us from connected car, from commercial fleets like trucks, lorries, taxis. And this approach is named, and I think you are already familiar with that, floating car data, FCD. So that's basically what we are doing. Although the C in the middle, car, is a little bit misleading because we are not only using data coming from cars, but also from mobile apps. So think about the usual navigation apps on your smartphone. This is all potential input data, raw data, as we name it, for us. Basically everything what has a GPS, which is important, and the router functionality can feed the location and is an interesting source for us. So with this, we are able to cover 5 to 10% of the entire traffic, for example, in a country like Germany. And this is by far enough to get reasonable representativity out of the data and to make good calculations. And then think about the huge amount of data INRIX is collecting almost every second in more than 50 countries in the world. So that means INRIX is getting really already anonymized data from our sources, which is all coming into our technology platform, which you see here in the middle. As we name it, our Fusion Engine, and from there, and there in the technology platform, there lies all the intelligence, the algorithms, the machine learning, artificial intelligence, which creates several data services like real-time traffic, I mentioned, parking, and of course, the analytics data. But what is the special interest of our webinar today here, and what is the data which is most interesting. It's called, sorry, it's called TRIPS data. Can you, yeah, thank you very much. Let's a little bit focus on the so-called TRIPS data. So as you have realized, the INRIX data is GPS based, which means it's very precise in regards of location. And this GPS data includes and is sending to INRIX so-called waypoints, which we are receiving in between 15 seconds and up to or down to 1 second. So in a 1 second frequency, we are getting this kind of data from the sources I already mentioned. And you can see that here in the picture a little bit as a scheme, you know, coming from below left going to above right, you see, you know, a few data points. And if you connecting these points, it will be possible to get trajectories of trips. Yeah, that's where the name is coming from. And it's easy to create OD matrices, origin destination matrices. Depending on which region you are defining, you can see where is it coming from, going to or going through a defined region. And this kind of data XYZ is using, and that is what Bart will show you in a minute. And as you have realized, this TRIPS data is basically historic data, which means we can provide the data today minus 24 hours, which is, you know, the day before today, yesterday, but we can provide data back to up to 2014. So for any kind of historical analysis. And furthermore, very important, TRIPS data can distinguish between different weight classes from vehicles, so such as passenger cars, delivery trucks, and heavyweight trucks. And this is because of the according data sources we have, and this is of course enhancing additional possible use cases as well. Next slide, Bart. Thank you. Yeah, and usually, you know, again, INRIX is providing this kind of data usually in a file, which is just a CSV file, and you see that here on the right side. So it's a little bit complicated, it's a little bit technical. So whoever is using our data from a customer perspective has to be able to work with this kind of data, you know, to visualizing it, to process it, to calculate it, to answer any question a customer might have. And as explained, XYZ now can be an easy way to get most out of this data and to handle it very easily. So the way it works is very simple. You feed the XYZ database with INRIX TRIPS data, and then using the GUI and the tool as such to define and create any kind of reasonable projects, which will now be shown in a few use cases we want to show you. Very easy way to get answered your questions. If you have any questions regarding the data, I'm happy to answer them in the following Q&A session. Thank you very much so far. Over to Bart again.
Thank you, Holger. And maybe before I dive deep into the data in the platform, Joe, we have another question.
Yeah, we do. So poll question number 2, what data sources are you using now? Options are video feeds, traffic counting data, floating vehicle data, I'm looking for good data, or other. So let me bring up the poll, and this one you can make multiple choices. Okay, let's give it a few more seconds. All right, I'm going to stop it there. In the poll and share the results with you. So again, another mix, but mostly traffic counting data and floating vehicle data. And I'm looking for good data as well.
Okay, that's good. So one of the many powerful things about using the waypoints and the trips data is that you know where the traffic is coming from and where the traffic is going to. And that's of course something just with counting is something that you don't have. So what I'm going to do now is I'm going to give 3 small example use cases of how people are using our platform with the trips data, and to give you an idea of the power of the data and also of the platform on extracting those insights. So what I'm going to do is I'm going to first create a new project, because I've been asked to do a short analysis on a small bridge in Hamburg, and it's called the Elbbrücke. And I'm going to create a project, and in this case, instead of uploading new data in the platform, I'm going to use an existing data set that I already had available from a previous analysis, and I'm going to attach it to my project. So basically, by doing so, this data set becomes available to the project. I'm also going to add a little background layer to add some context to the data. I can use a vector-based map or an aerial imagery-based map. And I'm going to use the visual analysis capability of the platform. So the first thing I'm going to do is I'm going to search for this bridge and zoom in on that area. And here we are. So here you see the data surrounding this area. And you see all the waypoints plotted on the map. And by default, we now see a heat map. And the first thing I want to do is basically look at what's happening on the bridge. So for that, I'm just zooming in on the map. And by zooming in, I'm basically filtering on the data. I'm just looking at what is happening in this area. And from the right side here, I already see, and let me just focus on this widget for a bit. I see the velocity profile and I see what is happening. I see that there's like 2 peaks. There's like a small peak here and a big peak here. So this gives me an idea that there might be some congestion in this area. So what I'm going to do is, the first thing I'm going to do is I'm going to try to plot the velocity on the map. So let me take velocity here, speed. Now, by default, the velocity in Germany in the entire data set can be quite big. So I will have to reduce my range of values that I want to map to the color on the map. And instead of using this 2-colored gradient, I'm going to use a more descriptive gradient that gives me more variation in the different colors for the velocity. So as you can see now, you see some variation in the 2 directions. And just to show you what it looks like in real life, let me disable the layer a bit. So you can see that it's a bridge over the Elbe here. And you see that in one direction, the traffic is quite different than in the other direction. So what I'm going to do is let's focus on this area. And for that, I'm just going to draw a shape on that area so that I can focus my analysis on that area. I forgot to use the shape as a filter, so I'm going to right click on the shape and I'm going to use it as a filter to just focus on the waypoints inside the shape. And this gives me the ability to just focus on this area. Now, as we can see, there's 2 different directions. The way that I can filter on those 2 different directions, and sorry for that, I was planning to scroll here a bit. What I'm going to do is I'm going to select a property in the data. And in this case, I'm going to use heading. And the reason why I'm using heading is because if you look at the heading widget here, it shows 2 peaks, one in this direction and one in the other direction. So just by applying a filter here on the heading, I can focus on all the traffic going north. If I would use the inverse of this filter, you would see the traffic going south. And this gives me the velocity profile. And let me focus again on this widget in both directions. So in this case, I'm doing the analysis on one map, but I can also do the analysis on two maps. So for example, I could say, okay, on the left map, I want to see the traffic going south, and on the right map, which I selected now, I want to see the traffic in the other direction. This immediately also gives me a comparison of the speed profiles, but it also gives me a comparison in the amount of traffic. It tells me that going north, there's 13% more traffic than going south. And now with the platform, you can do all these types of analysis in space, in time, based on the attributes in the data. And you can use your analysis to build up dashboards to communicate. And it is simply done as follows. You first configure all your filters and your settings. And then, for example, you say, okay, I want to see this data in the last day. And then when you push new data to the platform, then your view updates on that last day. You can release that, of course, again. So in this case, I'm looking at this entire week of data, and I want to make a report on that. So what I'm going to do is first, I'm going to add the map as a widget on my dashboard, and I'm going to call this traffic south. And I think it's Elbrücken. And I'm going to do the same with the velocity widget. So I'm going to add this as a widget, and also call it traffic south, and add it to the same group. And so you understand, you can do this with anything in the platform. And this way you can build up a dashboard that you can then communicate to anyone using, for example, a shared link. So the trips data and the waypoints data is super powerful in the sense that you have access to all the original information in those trips. For example, if I also now want to see where does this traffic come from through this area, what I can do is I just remove this inside filter, and instead I use a true filter. And let me just fit on the map. And now the platform shows you where does all this traffic come from. If I don't want to see the speed as a property, I can now maybe go back to my heat map, make my background layer a bit darker so that I know where it is. And this way now I see where does all the traffic through that small bridge in Hamburg come from. And that gives you a real good idea of the type of traffic passing. So that's the first use case. It's really the use case of mobility analysis. What is going on with the velocities, with the wait times, with the traffic origins and destinations. You can do that visually like I did, but you can also do that in trends, really focusing just on trends in the data, or you can also build the classical origin destination matrices using different areas. Now in this case, I only have one area. Let me give you a second example of an analysis, and that also fits into the smarter, cleaner, and safer. One of the big problems in cities is, of course, the safety of kids going to schools and the busy traffic around, and especially in Brussels. And I'm going to switch to a different project for that with a different data set. There is a lot of traffic. And what we're looking at now is it's an historic data set. And it's a data set that shows 4 weeks of traffic through the city of Brussels. So if I would zoom in on the city center, you would see again, it starts with looking at 2 million trips, but now we're refining. We're looking at the city center. What I can, of course, do is again, as before, I can switch my analysis to look at, for example, the speed profile, take a color map, that is descriptive. So I'm going to take this blue to red color map. I'm going to adjust my value range to some sensible values in Belgium, maybe even a little bit less. And that gives me already a very good idea of what is happening during that 4 weeks of data. And of course, you can then zoom in on a location of a school and start analyzing. Now, the platform also allows you to do something different. You can also just load in the locations of the school, of all those schools, and we call that areas of interest. And I'll show you how to do that. So I go to my data dump that I have, go to the INRIX webinar, and to my Brussels case, and there I have a JSON file. It's a GeoJSON file, by the way, with all the locations of schools in Brussels. So what I'm interested in is to know how does the traffic look like in the neighborhood of those locations. So what I'm going to do is I'm going to add a distance threshold of about 150 meters. What I'm also going to do is I'm going to group my data by type, and I'll show that in a minute on the map what that means. You see now that this data set is attached to my project, and if I go back to my visual analytics, you should see that those school locations and all the neighborhoods around are now those white circles on the map. So let me first maybe switch back just to look at the heat map. So what I want to do now is I want to use these locations as filters on my data. And this can be very easily done as follows. In the filters panel, instead of filtering on a property, I'm going to filter on an area. And in this case, you will see that I have 3 types of areas. And this is where this grouping comes in. I grouped all those points by the type, and that allows me to select a type in this drop-down box. So what I'm going to do is I'm going to select elementary school because that's the age of my kids. And that's also the age typically that kids will bike to school or will start biking to school or maybe even walking to school in a city. So I'm going to use this as a filter. I'm going to press on include because there's quite a few shapes now. I'm just going to hide them and focus on the trips data. And now what I'm doing is I'm actually looking at the same data set, but through the eyes of the neighborhoods of those schools. And I'm only looking at the speed profiles 150 meters away from those schools. And as you can see by looking at the speed profile, and let me just focus on this widget again, you can see that it seems to be mostly fine. It seems to be like between 15 and 20 kilometers an hour, which is quite good, 25, 20, 25, 30. But you also see there's some outliers here in this long tail. So what I'm going to do now is I'm going to apply another filter, and I'm going to make that a property filter based on the velocity. And what I'm going to do is I'm going to focus on those velocities above 50. So again, here, I'm going to include this filter, and the map will update. And you'll see that you get a different heat map, and you also see that the velocity profile has updated as well. So again, here, I'm going to use a heat map that is has a bit more color variation in the range of colors. And I'm going to use maybe a slightly bigger cell size as the default one to highlight those locations. So already now, from just looking at the red color, you can see which areas are sort of more dangerous areas for your kids to go to school, or maybe are areas that the city can focus on to reduce the speed that is going on in that city. So, of course, we are looking at the entire week. Maybe we should only look at school days. So that's another filter I want to apply, and I'm just going to exclude the weekend days. So now I have Monday to Friday, apply another filter, and then maybe I only want to look at the hours of the day when there are kids around. So maybe now just focus on the mornings, and let me take maybe between 6 and 10 when maybe there are some kids around the school. What I can then also do is I'm looking at a heat map of where there are many of those events, like people driving more than 50 an hour when your kids are going to school. So what I'm going to do now is I'm going to threshold this map. I'm going to threshold it, and let me maybe fade out the background map a bit so that you see better what is going on. So without thresholding, I would see all locations on the map. And with thresholding, I can say, okay, let me focus on the most bad areas for this filter. So now I'm going to zoom in, for example, on this area. I know now already that there are those issues with the velocity. So if I remove the thresholding again, and if I reduce my cell size again, and then maybe even remove my dark layer and really look at the satellite layer, I can see all those little waypoints of cars that were driving basically faster than 50 an hour. So use case for safety, but the data is so much more powerful to do all types of analysis on demand. Even when you're in a meeting and people ask, can you show this, can you show this? It's really easy because you have access to this raw data. As a final example, and I'm taking a lot of time, I know, but this one is a really exciting one. Maybe not so much for the people involved, but Holger, this is an area in Germany that is seeing a lot of problems.
Yeah, correct. I mean, Lüdenscheid, which is not a most famous city in Germany. However, there is a German Autobahn, a highway, the A45. And it turned out that, as sometimes it happens in Germany, that a highway bridge, an Autobahn bridge, is actually broken. It's not possible to pass it any longer, so it's closed for traffic. And you can imagine that on such a very important highway, that this will cause a lot of problems and issues. And yeah, we will see that in a minute.
Okay, yeah, so let me zoom in. So what you're seeing here is like a couple hundreds of millions of data points, 4 weeks again, but you see there's a little gap. We took 2 weeks in November and 2 weeks in December. So what I'm going to do is I'm going to zoom in on that area. The village is called, or is it a city, Holger, or a village?
Yeah, it's a smaller city. Lüdenscheid.
It's a smaller city.
Yeah.
Okay, so it's called Lüdenscheid, and what you will see is, and I will first do that just visually. What I can do here on the timeline, I can change my time window, and I'm looking now at November. And just pay attention on what is going to happen if I move my slider to December. Let me move it back just a second. I think you can see what is happening. So there was this whole highway section that you see here that actually doesn't show any or almost any data points anymore. So this highway section is closed off. There's a bridge, a couple hundred meters, I think, Holger. That,
yeah, correct. Yeah.
Will take years and years to fix. But of course, what you can see is it has a huge impact on the environment. And traffic is diverted basically off the highway in this area through all the other streets and also through the city of Lüdenscheid. And that's a real problem there. And with the trips data, you get full visibility on what is happening. You don't have to guess anymore or start measuring. You just get the data and you know what is happening. Let me show you how to do that. So what I'm interested in is to see what is the impact of this closure. Where is the traffic going? So basically what I'm going to do is I'm going to draw a shape here just before the exit. And I'm going to call it the south shape. And I'm immediately going to use it as a filter. And instead of looking at what is happening inside that shape, I'm going to look at the traffic that goes through that shape, but comes from that shape. And I'm going to call it as a from filter. So you already see now that this is traffic that goes through that shape and then later on moves in this direction. I'm going to do the same in the northern area. So I'm going to move all the way to the north to this area where the highway is open again. And I'm going to add another shape. And I'm going to call this the north shape. And I get a nice little warning from another tool. And I'm going to use a to filter. And basically now I'm filtering, and you see these two filters applied here. I'm filtering on all trips that go to the south shape before they go to the north shape. And this is what the profile looks like. So basically this gives me all traffic that goes through here, moves in one way or another, and in the end goes through the other shape. And you can see here on the bottom, you can see how much traffic difference that is. So what I can see immediately is that people are avoiding this area. People are avoiding this area because they know that it's going to be a big mess driving from here to here. If I would move my slider back to those 2 other weeks, you see a perfectly nice, fine, calm picture. Everyone is basically, or almost everyone, is driving along the highway in this time period. And in this time period, when the bridge is closed, you see this chaotic movement throughout the entire area. Also, if I would zoom in on the city of Lüdenscheid, it becomes even more extreme. And you can see that here on the timeline, on the histogram. You see before, there was almost no traffic passing through this area when going from the south to the north shape. While now, you're really seeing that there's so much traffic going through this area. And you can also see that it's not just following the main roads, it's also traffic following diversions, probably to avoid some congestion along those roads. If I want to quantify this, I can basically add another shape, and I can call this the true shape. And then I say, okay, I want to use this one as a filter also, and then only look at the traffic from south through this area to north, and then see what is going on. And this you can do with different shapes on the map, different areas. You can also upload the GeoJSON file with all the different areas and so on, and you can start quantifying and comparing those different things. For example, if I'm now interested to see what is the speed profile on this area, the only thing I have to do is to zoom in on the area, and I can immediately see what the speed profile is in this area during this time period. If I want to look at how it was before, I just disable my filters again, move back to my before, and yeah, you would see a different profile. And that's really the power of the TRIPS data, that you can just do basically any analysis because you have access to all the original data points. Now our tool doesn't just work with TRIPS data, it also works with other data sources. Let me give you just a quick example. For example, if you have air quality measurements, such as NO2 or small particle matter, our platform can also handle that. So you can ingest this data and you can do your analysis. You can also combine it with the INRIX data. So for example, in this picture, we are looking at regions in Europe with high exposures of NO2 during longer time periods. And that's also a data source. But also from INRIX, there's many different types of data sources that they provide. For example, this is a data source with park in, park out events. And that tells you where do people park in a city. And again, with the same techniques, with heat maps, with thresholding, you can identify where are the bottlenecks in the city, or where are the most active areas where people park, and so on and so forth. And so you can think, if you have like EV use cases, quality of life use cases, bike use cases, all those cases have data sources with spatial temporal data where our tool can be used. A final really exciting evolvement, and Holger and his colleague Christian from INRIX showed me that, and I'm super excited about that, is that they now have data updates of less than or almost a second. And that means that you can actually start computing acceleration on this data, because the data points are so frequent in time. And let me show that. I created a bookmark for that to show you what that looks like, acceleration. And what you're seeing here is actually very similar again in the resulting picture, but the analysis is quite interesting. So what I'm doing is I'm taking TRIPS data where I know that the frequency in update rate is between 0 and 2 seconds. So basically, I know that I have very frequent points in the data. And then I'm filtering on acceleration, and I'm filtering on positive acceleration, looking at data points where there's more than 3 meters per square second acceleration. And that means that in those areas, and I can do the same trick with the thresholding on my heat map, I can now identify which areas in the city see a lot of acceleration. And basically, as you know, for a car, when you drive a car and you accelerate, the emissions go up. And for clean cities, for green cities, for smart cities, this can be an indication of where to focus your efforts and where to look into putting measures in place, or maybe educating drivers that they shouldn't accelerate as quickly as that to result in a more clean environment. So you see the possibilities are endless to become smart, clean and safe. I hope I could give a little bit of a flavor of the power of the data and the power of the platform. And yeah, we have a couple more slides to close off, and I hope we can have around 5 minutes for questions maybe later. But first, Joe, there's another poll.
Yeah, just get through these quickly. So the next one is, what self-service analytics tools are you using now? Power BI, Tableau, a custom-built solution, I need a good tool, or other. Let me bring that up for you now. To make your selections, again, it's a multiple choice. Okay, all right, I'll close it off there in the poll and share the results.
All right, some Power BI users. We also really love Power BI, but also some that built their own custom solutions. That's really interesting also. Tableau doesn't seem to be popular. That's interesting to know. One interesting note about Power BI is that they basically cut off the amount of data on the map at some point. I don't know the exact number, but I think it's around a couple, 3,000 or so. So that's really something where we see that we can help you out if you're stuck with that. So just to summarize, the benefits that the data, the TRIPS data, the INRIX data, and the tool bring to you are basically can be placed in 4 categories. The first one is you have to change your mindset to go from infrastructure to data. I know you might have the impression that data is expensive, but think about how expensive infrastructure is. So data is cheap compared to infrastructure. It means also that you can be much faster. You can do analysis on a much bigger scale, on a much different scale. And you can really save investments of millions and bring that down to thousands of euros. Instant insights, even for big data, that's where our tool comes in. We've seen people working on Python scripts for months and months, and then later on they have to do another analysis and they have to reiterate that. And that's what we try to solve. Also, we put a lot of emphasis on usability, on the ability to work together, to communicate with the tool. So it's really self-service. And what's also important, bring your own data. You avoid the lock-in of a tool, of a data vendor. You can bring in other data, you can bring in your own data, you can bring in new mobility data, you can bring in weather data, sensor data, anything that's spatial temporal. And then, of course, the sharing of insights is something that we see many of our customers benefit from, that they build dashboards and they share them with their audience. So just as a quick roundup, without XYZT.ai, you would need more data scientists, a lot of custom coding. We see that it's a real challenge to handle large data sets, with the unfortunate result that data remains locked and is not used to its full potential. And I've dozens of examples, companies where that's the case, unfortunately still. And also it's a high cost to work with the data. And that's why we try to be a solution for that. Self-service, our goal is that an analyst, anyone in an organization should be able to use the tool. It should be intuitive. You should be able to ingest multiple data sources. You should be able to share and collaborate together and really bring down time to insight from months to minutes, and ultimately get to a smarter, cleaner and safer environment for us all. I think that concludes it. I think, Joe, one final question out of interest for us to know whether this was interesting for you, whether you want to know more.
Yeah, indeed. And just a reminder, if you do have any more questions, then please put those into the Q&A box for us now. But yeah, the last one is, are you interested to find out more? So yes, about the Vision Analytics tool from XYZT.ai, yes, about the trips data from INRIX, or yes, about both, or no, there's no interest for now, thanks. So let me bring that up. We have got a few questions coming in as well, so we've got 4 minutes left. So we'll try and get those answered before we finish. Ends up all there. So good. Yeah, we will. We'll be in contact with you. About those afterwards.
Okay, we see a lot of yeses. That's good. I hope you didn't feel obliged to answer yes there. We honestly want to help solve your problems, Holger. That's why we are in business. Okay, I would like to thank Holger and also Christian from INRIX, who has been a tremendous help in getting the data. Holger, thank you for being here. And
more than welcome. Thank you.
And yeah, I think there will be some questions.
Yeah, let's dive into those very quickly.
Any questions? Yeah.
Yeah, just first of all, one about combining data on there. So about whether data sets used on the platform, would they be integrated into the traffic prognosis, for example, less volume during rain?
Yeah, it's a very good question. So in the platform, it's bring your own data. So basically you can ingest any data as long as you can represent it as locations in space and time with attributes. You can combine data sets in different layers on the view. You can use them together. For now, it's in an analytical way to investigate, to look at what is happening. Predictive, we don't do yet in the platform. It's definitely something we will be doing in the future, but it's not something that is in the platform for now, if that answered that question.
Great, thanks, Bart. Next one for you, Holger. So it's a question around where you get the data from and collecting them from, do you collect them from GPS modules directly, or do you buy them from a third-party provider? The penetration rates and the length of the trajectory seem to be very ambitious.
Yeah, a few questions actually. So where we are getting the data from? So yes, we have contracts with our direct sources, so we don't have GPS sensors by our own in the field. As I said at the beginning, mostly coming from connected cars. All the modern cars, even older ones, meanwhile, have eSIM in their dashboard, and this kind of connection is sending a constant stream of GPS data to the OEM. The OEM, the automotive supplier, actually is anonymizing that, and then we will get the data. Same with the mobile apps, as I mentioned. So we will get already from partners anonymized and GDPR confirmed data, which then, and that is what INRIX is doing, we are aggregating them into our platform Fusion Engine, as I said, and bringing out the service here. So what was the second question? Sorry.
Yeah, the penetration rates and the length of the trajectory seem to be very ambitious.
Yeah, penetration, as I said in my quick overview, that's measured. So we have some, especially in countries like Germany or Middle Europe, we have a penetration rate by covering 5 to 10% of the entire traffic. So if 100 cars are going over in a certain time, we are getting 5 to 10 out of them, which is a very good representativity. The trips length as such, that has something to do with GDPR compliance in one thing. Of course, we have to go along these legal obstacles here. What is true as well, if let's say a car turns off the engine, then it stops sending data. So that you have to take into account that this is going to happen. If a car is standing longer than a certain time, which is definable, something between 5, 10, 15 minutes, then we will lose the ID from the car or the mobile phone as well. So yeah, there are some restrictions, but we could not highlight that in such a short time frame. You can handle that, but yes, there are some restrictions. However, there are enough of data which even shows longer trips and trips lengths. Yes.
Well, thanks, Holger. Bart, you were showing about the accelerations, but what about decelerations as well?
Yeah, that's fine. That's in the data also. The negative numbers are there. I just filtered on the positive ones there too. But sudden deaccelerations can also be indicative of dangerous areas, for example, where there's a lot of almost accidents or almost crashes happening. So that's very useful also. And there on the map, what I showed was just 1 day of data. But you can imagine if you have an update rate of every second data point, you can have a lot of data. And if you combine multiple days, you can get a quite good picture of hotspots of the acceleration as well.
Yes, thanks. And then about the subscription. So yeah, is this purchased or a subscription-based model?
Is that for the tool or for the data?
Well, maybe if answer both, I think.
Both, yeah.
The tool is subscription. The tool is subscription-based. We have different tiers going for a license for a single analyst to a team to an organization. So we cater for that, but we can provide that information. I think, Holger, you have different models.
Yeah, actually, if you think about it, if a customer would make a decision to go for the tool in combination with the data, we would provide a data set. It might be 6 months, 12 months, whatever, for certain region, and that is what we have to define upfront. Once this is defined, then a customer will acquire a data license. And the time to have the right to use the data, and then this data will be put into the database from XYZ. So if you want, that is a subscription model as well.
Great. And then we are a little bit over. So last question here, one from David, and it kind of goes in with the coverage sort of question as well to you, Holger. Can you tell us about the coverage sort of worldwide, and do you address any of the Chinese market to monitor tracking behaviors?
Yeah, Chinese is complicated as always. So yes, we have it on a worldwide basis, up to 50 countries all over the world. China, I would like to have a discussion offline with that. That's a little bit more complicated. The data has to be in the country and this kind of things. Potentially we can provide it, but if there's any interest, please approach me directly on that.
Okay, wonderful. Right. Yeah, I think we'll stop there. So a little bit over, but again, I'd like to really thank you, Holger, for taking part, and again, same as Bart. Thank you very much, Christian, for helping us. He is on the webinar as well. Yeah, we will make sure that the recording is sent out within the next 24 hours in the email, so please share that with your colleagues as well that may not have been able to attend. But again, thank you for everyone joining us. I'd like to wish you a very good rest of your day, and we will see you on our next webinar. Thank you very much.
Thank you.
Thank you.
Bye-bye.
Bye.